Welcome to day 5 of Untitled Code 2024. Today we're going to solve a print queue problem. Now we would get an input which is like this in two parts. The first part is basically in form of x, y. This means that where x is a number, page number, and y is also a page number, and this is a rule saying that the page number x should be printed before page number y. For whatever reason, we don't know, we just know this is the rule. So looking at this page should be printed before this page. Or here, this page should be printed before this page. Now these are the rules. And one more thing is that if we have something like this doesn't necessarily mean that 13 is immediately after 97. It might be cases that there are pages in between these two, but it's always 97 before 13, these two pages. Then on the second part, which is this part, we get the number of the page that need an update. So for example, this row means that the update should happen on the page 75, 47, 61, 53, and 29. Now we need to figure out which updates are already in the right order. Okay, so what do I mean by that? So if I look at this, I can find 75, 47 somewhere here. Look, I have found it. I have this, which means that 75 is before 47. Also 75 is before 61. Okay, this part. So if I look at here, I could find 75, 61. I could also find 75, 53 like this, and 75, 29. So 75 is preceding all the pages according to this rule. So 75 is in the right place. Then we have 47. So if I search for 47, you can see that 47 precedes 61, 53, and 29. And all of the rules are satisfied. Great. Then we have 61, 53, and 29. Great. So this is a correct rule. Correct row, so to say, or correct update. But for example, this one, we have 75, 97. If we go and search for 75 like this, you can see I cannot find any 75, 97. But I have it the other way around. I have it like this, which means that this is in violation with this rule. This is not a correct rule. Or for example here, 61, 13. So if I go here, 61, 13 is correct, but I believe 29, 13 is not correct. So you can see that we have 29, 13 here, but here in the example we have 13, 29, which is not the correct order. So these two rows are not correct. Similarly, this update is wrong as well. Now we need to find all the ones that are correct, get the middle page number for whatever reason, and then add those middle numbers together. So in this example, we would get this value, this 53 and 29, and add them together. Will get us to 143. So think about the puzzle, and when you're ready, let's dive into the code. Okay, as always, I have this read file that would read the file for me. I would get the data, and here I would split the data by two new lines. Now I'm on a Macintosh machine, but it might be like /r/n on Windows, I'm not really sure. You need to go and check that. Now this would split the data in two parts because I have a new line here. So this will be the part 1 and this will be the part 2. They are named as rules and updates. Now to make life easier, I would also split these rules to two parts, the left and right. So if I'm getting this, I would split by this pipe symbol and I get this value and this value. That is done here. So I'm getting the rules split by new line to get each of these, and then again split by this to get the left and right part. I don't care about converting these to numbers because this is not needed. The string would work as well, and for updates as well. Now on each of these updates, the thing that we would do, let me first close the part 2 so we are not like mixing up everything. So in the part 1, I would get the updates and I would check to see if they are ordered or not. If they are ordered, I would get the middle one and add it to the value that I want to return. If it's not ordered, I would leave it as is. And that is done basically like this. So I would get the updates, which is already an array, and then I would reduce it. As you know, reduce will take a callback function and work on every item of update, and in the end it will return a single value. Now, for each of these update rows, which is one of these, again, we would check if it's ordered or not. Well, of course, this is not a function in JavaScript. We need to write it. But let's imagine that we already have this function. If it's not ordered, we don't care about it. So we return the ACC as it was, the accumulator as it was. Otherwise, we get the middle index of the update list, and then get the value of that index by this, convert it to number because we want to add it to the accumulator, and then add it to accumulator and return it. And in the end, this will result in getting the part 1 value. Now, how does this part work? Let's go and see. So looking at the code, we can see that for each of the updates that we have, let me copy one of the updates here so we know better. So for example, for this update, we get this value and this value. And we check to see, do we have a rule that is like this, 47, like this? Do we have a rule like this? If it's like this, then it's fine. This is working correctly. If we don't have this rule, then this is not ordered. So probably 47 shall go before 75. Okay, so by doing this simple comparison here, we can see that if this list is ordered or not. Again, if we look at here, we look through all the updates from here to here, and we don't need to include this because when we get to this, we will check this with this one. So going from 0 to update.length -1, these ones, then we will take a look at rules. And we try to find the rule which part 0 of the rule, or this part, equals to this, and part 1 of the rule equals to this. If we find this, then we are fine. If we can't find this, this is not in order. Okay? So by the end of this, it would give us the answer properly. So let's for now mark this and go to part 2. On the part 2, it gets a bit trickier. Here, for each of the incorrectly ordered updates, we need to find the correct order of the pages and then do the same calculation. So for example, we have it like this, and here these two are not correct, so these two shall be replaced, and the correct order will be like this. Again, we get this value and continue. But here it's a bit trickier because it's already messed up, and then 13 shall go to the end, 47 shall go here before 29, and so forth and so on. So we need to get this and somehow figure out the correct way that this shall be ordered. So let's think how we can do that. We have this list. We don't know which one shall go first, which one shall go last. We only know that which one is before which one, according to this rule set that we have. Okay, the thing that came to my mind is that I would create a dictionary for this, saying that, okay, 97 shall go before, for example, 3 of these. Then 75 shall go before 2 of these, and so forth. There will be one, in this case 13, which has no preceding page number. Okay, when I found that one, this is going to be my last page. Let me show it in the code. It might be much clearer. So let's close this one. On the part 2, it's kind of the same as part 1, but here if we check if it's ordered. If it's not ordered, we return. Here, if it's ordered, we return. We don't care about the ordered one. We are going to basically make the unordered one ordered by this function that we are writing. So this is the part that is going to be tricky. So let's go and see how we can order one list. Let's go here. First, let me remove these parts from here, so we have only one line. It's much more clear then. Now on the order list, we again get the update, the list that we want to update, and the list of the roles. Now we would create a dictionary of all the numbers that are there. So again, let me copy this. And go here. Then our dictionary would be an object with key all these values, and the value is the number of the pages that are linked to 97. But how can we do that? So let's look at here. We have the update for each of these items. We get a page number, and then we say that dictionary of that page will be on the rules, filter the rule that are starting with this page. So when I get 97, I would go here and find all the ones that are starting with 97. So this one, this one, this one, this one, and so on. And from those, I would get the rule number 1. I would say, okay, this one points to 13. This one points to this one points to this. So if I mark this and go here, okay, now we can see that, for example, for 13, we don't have any page that goes after it. So if I go here and search for 13, you can see that none of these starting with 13, which is great. So 13 has no page after it, but for example, 29 is the page that is linked to 13. So this shall go in the last, and this shall go before that. Now, as you can see, for example, 47 here has a lot of dependencies, but we want the dependencies that are basically part of this. So for example, this 47 connection to 53 is not required here. So we would filter that part out as well. Now if we look at this again, we can see that 13 is looking at an empty array. Then 29 is looking at 30. Then 47 is looking at these two. So this shall go last. This shall go before that because this has only dependency to 13 and we have covered it. 47 has dependency on these two and we have covered these two, so this shall go on the middle, this shall go on the second place, and this shall go first. So the correct order would be 97, 75, this, and this. Now, the thing that we should do is like this. We should take a look at this object and see, while there are values here, go and get the one that has no value. This is going to be your last. Get this value, remove this line, remove 13 from all of these arrays, and add 13 to the correct order. So that is happening here. First we find the key with an empty array, which is this one. We get the keys of dictionary and find the key that has the length of 0. Now we want to remove the key from all the values, so we want to remove it from here, from here, from here. For all the key in the dictionary, for all of these, dictionary of key is the dictionary of key filtered by this one, so it will remove all of these. Now we need to remove these all together, so we would delete it, and then we need to add 13 to the end of the ordered list. So we would unshift this and we would continue this until there is no values left inside this object. Okay, so one more again. First we would find out this one that has no dependency, then we remove it from all of these arrays that are here, remove the whole entry from the object, and add this value to the ordered list that we want to return. Okay, now when this is done, we go and return the ordered. Okay, so let me remove this, go back, and here in part 2, when we get the ordered, the rest is basically it's just as what we have here. We get the middle part and then add it to the ACC and then return it. Well, I hope this was clear for you, and I hope you enjoyed the video. If that's the case, don't forget to subscribe to the channel, and see you in the next video.